Hello. Today I'm going to be going through one of our circle rules uh, in our circle theorems. And the title of this rule is Angle in a semicircle is 90 degrees. The angle in a semicircle is 90 degrees. Let's get into this theorem, understand how it works. What are the properties of this theorem? What I have right here is a circle, and the center of my circle is point O. Now I can call this straight line here AB, and AB would be a diameter because any line that passes through the center of the circle connecting 2 points on the circumference is a diameter. Now, when you're working with circle theorems, never assume the center unless it is referenced, mentioned, or otherwise. We cannot assume that any line in a circle is a diameter unless we are sure it passes through the center and we are sure that what we are given is the center of the circle. So the center must be clarified. It must be 100% clear. Now, in our illustration, of course, O is our center, so no doubt AB is a diameter. Now, remember what a diameter does. It divides our circle in half. So what I have right here are two semicircles. And in one of these semicircles, I am going to draw another chord to point C right here and connect that point C to point B like that. And what I now have is triangle ACB. Now, the angle C, which is opposite to our diameter, will be 90 degrees. This is the angle which is 90 degrees. It is the angle that is opposite our diameter and necessarily touches the circumference. Make that observation. The point C must necessarily be on the circumference. So if I have a different case like this, and I have this point and I would call it point D. Now the angle D wouldn't be 90 degrees, cannot be 90 degrees because it does not satisfy the condition. It does not stop at the circumference. It does not touch the circumference. So keep in mind, this theorem works under those two conditions. What is our first condition? The line AB must be a diameter. What's the second condition? The angle in that triangle formed with the diameter must be on the circumference. If this is true, then no doubt that angle is 90 degrees. Now, I have a quick question here just to show you how to use this theorem in questions. Our question says, in the diagram, O is the center of the circle, find X. Now, if O is the center, what does that tell you? Absolutely, this line is a diameter, right? The line I am highlighting right now is a diameter. And if that line is a diameter, what else do we know? The opposite angle to the diameter in the triangle is 90 degrees. So we have a triangle in that semicircle, and we have an angle opposite to the diameter. That particular angle is 90. What else do we know about triangles? We also know that angles in a triangle add up to 180. So I could take the sum of these three angles and form an equation. If I add 90 degrees plus my 4x plus the other angle x, the third angle, I'm expecting that the sum of these three angles should be 180 degrees. From here, I can use algebra and reverse operations to find out what x is. So I collect my like terms, 4x plus x is 5x. Then I can also move the 90 degrees to the other side and subtract it to give me 180 minus 90, which is 90 degrees. Then I can divide the other side by 5. Since 5 is multiplying, if I reverse it to the other side, it will divide. So I have 90 divided by 5. Simplifying this, I have my solution as x is equal to 18. So this is how we use this particular theorem. When we started out in the question, we were not told that this angle was 90 degrees, but because we knew that once you have a semicircle and you have a triangle in a semicircle, such that one of the points on the circumference is opposite to the diameter, that particular angle in the triangle will be 90 degrees. And we also combined with our knowledge of the properties of a triangle, the angle properties of a triangle. So when you're answering questions in circle theorem, you need to combine your knowledge of the angle properties in shapes together with angle properties in circles, or our circle theorems. Put together your pre-existing basic rules of angles in shapes together with circle theorems. One last look at our rule. The angle in a semicircle is 90 degrees. And just to point out the fact that our point C does not have to be located where it is right now. I could have drawn this in a different way, like that, and then like that. And I could then position my point C here. This angle would still be 90 degrees. I could also have drawn it in the bottom semicircle. Remember, it's angle in a semicircle. So let's use the bottom semicircle this way. Okay, like that. And this particular point C here would be 90 degrees. Let's check it out. It's opposite our diameter, and it's in a triangle, and it touches the circumference. That angle definitely is 90 degrees. Watch out for more upcoming videos where we go through our circle theorems one by one.